Hey everyone, we just got done taking a look at the Industrial Revolution, what it was, how it spread or diffused, and its impact upon modern day. In looking at Key Issue 2, there's a lot of really important ideas that I want to share with you, that I really want you to understand, mainly because what's not outright stated but really significant is an important theory that's addressed but not referred to, known as the theory of industrial location. Its creator, his name is Alfred Weber, created in 1909. And the big idea behind it is selecting optimal factory locations. And you're asking, why is that important? Well, it has a lot to do with minimizing land, labor, and resource and transportation costs. So, in the context of modern day, why do factories pop up where they are? That's really what we're trying to get at with this. So really, by the time we get done watching this, I want you to answer the question at the top using Weber's model. How do we determine where to locate a factory? A couple of terms we've seen before, site and situation, so let's revisit these. Site is the human and physical characteristics of a location. In the context of industry, we're worried about land, labor, and capital. So if you're building something, what natural resources that are needed for the products that you're producing and eventually selling is nearby where your factory is. Labor, who's working in your factory. Capital is the finances and those investors who are important in keeping the business alive. So when trying to figure out where to place your factory, a couple things to keep in mind. So, if you were creating a lumber factory, it only makes sense that you would choose land of the three things listed above because your factory would be nearest the forest where your product is. A tech company, capital would be very important because in Silicon Valley, investors and a workforce is necessary to produce whatever tech product you're creating. In regards to manufacturing toys, you would want affordable labor, which often might be found outside of the United States. So let's bring it back to Alfred Weber's least cost theory, or better known, the theory of industrial location. So let's start with this. It really comes down to a couple of factors: transportation costs, labor costs, and raw materials. Those are the three that you really need to be familiar. Again, I want you to think like a business owner. The selection of an optimal factory location has much to do with the minimized cost of land, labor, resources, and transportation. That's kind of what you see in this diagram here. So when we look at the Weber triangle, P represents the production site or the factory. S1 and S2 represent the source, your raw materials that you're producing. In your book, I believe they call them input. M would be the market or where your product is being sold. In this case, let's say they were building mailboxes. S1 might be the lumber that would be needed for the posts that would be created. S2 could be the steel that would be produced that would make up the actual mailbox itself. So in this case, if we're taking a look at the cost of moving your good, S1, which would be the wood, and S2, the steel, to the production site, the equal distance and shipping costs dictates the market location. So let's say the cost of moving the wood, moving the steel was the same price. This is where it would make most sense to have your goods produced. Weber also states that two weight-losing materials, otherwise known as bulk-reducing manufacturing, results in an intermediate location. So let's say the wood that is eventually going to the production facility and the steel are very heavy items, but eventually made lighter. It's okay that the production facility is closer to the actual goods rather than where they're being. This brings me back to the idea of situation. So again, think transport. What should the manufacturer be closer to, the raw materials or the market? In the case of a bulk reducing manufacturing, you always want to be closer to the raw materials. As it says, a lumber company, their raw materials, the trees, are the heaviest part, so it's easier to process them closer to the factory and then ship them out. Same thing with cars. In this case, you want to be closer to the market because the individual pieces might be lighter and easier and cheaper to ship. So again, when we're talking about heavier items that become heavier raw materials that become lighter items, we're talking about bulk reducing. So the final product weighs less than the source or the input. So typically you're going to see the production facilities closer to the raw materials than you would from where they're being sold at market. So let's take a look at these three figures to give you a little bit more context about bulk reducing manufacturing. So if you take a look at figure 1, it shows that the processing plant, again, let's just say that these are wooden posts that are going to Home Depot, is somewhere between where the forest is, where you get the trees to eventually make the posts, and then the market itself. So the steep slope that you see going from the source, the forest, to the processing plant where the post is going to be made, represents the high cost of getting your raw material to the processing plant. We can also see from this figure that the cost of getting your wooden post from the processing plant to the market, let's say it's Home Depot, isn't all that expensive because, again, it is bulk reducing, it is losing weight, or as Weber says it, the weight losing case, when it goes from the processing location to the market. So look at figure 2. Figure 2 moves the processing plant closer to the source. So again, the forest, the processing plant is where the posts are being made. Notice what happens. Yes, it's still expensive to get the source to the processing location, but in figure 2 we see the decreasing cost of transportation because of the fact of the processing location is closer to the source. So then where you see my cursor is the price of moving your posts from the processing location to Home Depot. Compare that to what was in figure 1. Look how the difference of the prices. In this case of moving the processing location closer to the source, the price of transporting goods is significantly lower. Figure 3 is the ultimate bulk reducing idea, where in this case the forest, our source, and the processing location where the post is made are combined on the same land. So literally there is no cost of transportation from the source to the processing location. Instead, the only cost is from the processing location to the market, and as you notice, if you take a look at from figure 2 and figure 1, the cost in figure 3 in getting to the market is significantly lower. Again, what these three figures illustrate is bulk reducing because the input, or the source, wood being timber or wood, has a high transportation cost due to its weight, more so than the final product of the post. The other category that influences the situation of industrial production is when a product involves a number of inputs or things that are eventually going to make up the final product. They're combined to make a final product that gains weight or volume in the production process. This is known as weight gaining, or more commonly known as bulk gaining manufacturing. In situations when we're looking at bulk gaining, factories tend to be closer to consumers because the cost of transporting the finished product is more than transporting the inputs. Cars and refrigerators are good examples. The soft drink industry is another really good example. So let's take a look at the soft drink industry to understand bulk gaining industries. Since the principal input in soft drinks, let's say in this case 7-Up, is water, which is pretty accessible virtually everywhere in the developed world, cans and bottles and the syrup that makes the 7-Up are transported to the factories because the idea of transporting water is really not necessary considering it's available in many locations and it's extremely heavy. So let's take a look at these figures to get a better idea about bulk gaining industries. In figure 4, 5, 6, let's take the example of Pepsi. They have a processing plant distribution facility in Chicago that makes their beverages and ships them to 12 Midwestern states. In this case, our source is going to be the bottles or cans and the syrup that makes the pop. The production processing location is going to be where water is added and the beverage is carbonated. The market is going to be whatever stores the pop is sold in. Figure 4 has the highest transportation costs due to the fact that the finished product is heavier than the sources that it is made up of. And the price of moving its good from the processing location to the market is extremely high. So this would almost be like the idea of making the product in Chicago but selling it to Alaska. It wouldn't make much sense. In figure number 5, we move the processing location closer to the market. So again, let's say this is Chicago, but the market is Madison, Wisconsin. Due to the fact that the market is significantly closer to the processing location, the cost of moving and transporting that product is significantly lower than what we saw in figure 1. And then again, figure 6 is very much so like the figure to the right in the previous example that we saw, and that this is almost as if the source came directly to the processing plant and the market was in the area in which the processing plant was also located. So made in Chicago and sold in Chicago. So just as a reminder, bulk gaining as finished product weighs more than the inputs of what is comprised of. In some cases, inputs or raw materials need to be transported from the source to a production facility using multiple means of transportation. So as you read, trucks are cheap and used for short distances. Trains are harder to load than trucks, but efficient when goods are moving coast to coast with no stops. Ships are slower than land-based transportation, but can move more heavy materials across bodies of water. And air transport is expensive, but it's efficient for moving high value or small bulk items quickly. So when we use two or more means of transportation, we're going to refer to the place at where one source of transportation, in this case ship, changes over to the factory and then it is taken out via truck as the break of bulk point. It's the location where the transfer of transportation modes is possible. So another good example could be seaports where a truck might drop off something, or an airport where, let's say, a FedEx truck picks something up from a FedEx airplane. The second factor of Weber's theory of industrial location is labor costs. So labor costs reduce profits, so a factory might do better farther from raw materials and markets if cheap labor is available. Oftentimes now we see China and Mexico as major sources of cheap labor for American companies due to the fact that labor is more expensive than would be found in the United States. So while labor is important, I want you to just focus on the idea of transportation for a moment. Take a look at the map that you see on the right here. What I want you to try to figure out is that question at the top. Where is the best location for a steel manufacturing plant based upon what you see? Solely based upon the weights of the inputs. In this case, iron ore and coal. Nothing about limestone is listed. Remember, this is a bulk reducing industry as the final product weighs less than the inputs. Let's assume that the market is going to be somewhere in the Midwest. I want you to pause it for a minute. Take a look, think about it, and let me know what you come up with. If you said that the area where the factory should be is somewhere in the Midwest, whether it be near Chicago, Gary, or somewhere in the lower east side of Wisconsin, you would be right. And the major reason is because we see the major flows of both coal and iron are in this area, but as coal is the more expensive, and as we're selling in the Midwest, this would be the most efficient place for the manufacturing plant to be. The last factor of Weber's theory is known as agglomeration. When a large number of enterprises cluster together or agglomerate in the same area, they can provide assistance to one another through shared talents, services, and facilities. This concept of agglomeration can be applied to many industries, but a really good example is malls in the United States. Having numerous retailers located within a single area draws customers interested in a number of products, and individual customers are more likely to spend money not only at their initial destination but also in surrounding businesses. So as we take a look at a map of the Deer Park Town Center, if my wife saw a bag at the Vera Bradley store, but then we just so happened to walk into J. Crew and saw some shoes that went with it, that would be a really good example of agglomeration. The fact that restaurants are nearby also would play into that. So I would be out a little bit of money that day. On the outside of Weber's model looking in are Footloose Industries. These are businesses whose location are not tied to resources, transportation, or consumer locations. Examples could include customer call centers or any other business that would perform the service with wherever they so choose. So as we finish up talking about Weber's model, take a look at this diagram and consider transport costs of a car's components. Where would you locate your assembly plant?